Everyone, today we'll be solving the question longest increasing subsequence. It's a pretty um, standard question which is used to solve other question as well. So yeah, let's solve it. In the question we have to find longest increasing subsequence, and I hope you know what subsequence actually means. So yeah, I'm going to be using a recurrent plus memoization approach for it. So yeah, let's go. So first of all, initialize the size of our the vector, that is num sort size, and I'll initialize my integer n here so that globally we will be able to use it. Now I'm just gonna return solve 0 comma minus 1. Now I will tell why I'm writing the 0 and minus 1 there once I start the solve function. That is, let's write solve, and what are the parameters here? First int I comma int p comma I'm just gonna copy it here and let's go. Yeah, now I'll tell you why I write int and I also. So what I stands for is the current index that we are examining about, and p stands for the previous element. Now why previous? Because in the question we will find that we are going to be skipping every time no matter what happens, but to take we will have a condition. We will, for some numbers we are not going to take them. So there comes a problem that if we are not taking a number, then how we are going to keep the track what was the last number that was taken. This is the reason why we are using integer called p, which actually saves what is the last one that was taken. It will solve the problems. Yeah, so initially we have taken it as -1 because it means that we currently do not have any teacher save. So let's write our initial case, that if is equals to, which means if we reach last element, then we just need to remove we need to get back to the recursion. So if so let's skip. We are going to be skipping every time, and skip equals to I comma here skip I plus, because we have to skip to the next term, and p. Now we need to write take. So initially I'm gonna take as 0, and I'll write the take condition if p is equal to minus. What does this mean? P is in the first term, so we are allowing it to take, because first term we have to take it, or else we will not be able to move further with our array. So first term we have to take, and this is the main condition. If our current index is greater than the previous index that we chosen, then we need to initialize take, which is equals to solve, go to next term, I nums plus 1 our answer, that is we are adding it to our answer, that is why plus 1, and at the end we are just gonna return our max of skip comma take. Let's try to run it this much. We have not done memoization here correctly. Okay, it runs. So let's do the memoization. Let's first write the if condition of memoization here. If p is not is equals to -1. Why I'm writing here? Because we do not want a negative index in our array. We also need to initialize dp. Here I'm naming it t for my convenience. Okay, so this is done. And if t of I p is not -1, then I'm just gonna return t of I comma p. Similarly, I need here condition. Also, we need to write a condition here as well, so that we don't actually end up using it. So this is if p is equals to -1, then this, and at the end we are just gonna write meme set t -1 size of t. Yeah, it works. Let's try to submit it. Okay, it runs. Thank you for watching.